Welcome to the session on differentiation, implicit differentiation. The objectives for this session are to differentiate functions which are defined implicitly. Not all equations can be arranged in the form y equals f of x or x equals f of y. Such functions can sometimes be differentiated implicitly without rearranging them. An equation given explicitly is given in the form y equals f of x. Equations involving functions of both x and y, such as x squared plus 4x minus 7y plus 3y cubed equals 4, are implicit equations. Now, from the chain rule, we have that the derivative of f of y with respect to x equals f dash of y dy dx. We can use the following results for implicit differentiation, as shown on your screen. When differentiating implicit equations, expressions for dy dx will usually be given in terms of x and y. Let's now take a look at an example. Pause the video and have a go. Press play when you're ready to view the solution. In this example, given that x squared plus 6x minus 8y plus 5y cubed equals 17, find dy dx in terms of x and y. So let's solve this. We begin by differentiating the expression term by term. So differentiating x squared plus 6x gives us 2x plus 6. And using the formula d dx of y to the power n equals ny to the power n minus 1 dy dx, we have that the differential of minus 8y is minus 8 dy dx. And using the same equation, we can differentiate 5y cubed to give us 15y squared dy dx. And of course 17, the constant, differentiates to 0. If we rearrange this and factorize, we have dy dx times 15y squared minus 8 equals minus 6 minus 2x. Which gives us dy dx equals minus 6 minus 2x all over 15y squared minus 8. And now for another example. Pause the video and have a go. Press play when you're ready to view the solution. In this example, we're required to find the equation of the tangent to the curve with the implicit equation x squared plus 3xy squared minus y cubed equals 9 at the point 2, 1. So let's solve this. We begin by differentiating the equation with respect to x. X squared differentiates to 2x. We can differentiate here 3xy squared by applying the chain rule to give 3y squared plus 3x times 2y dy dx. Minus y cubed differentiates to minus 3y squared dy dx. And so if we tidy up and factorize, we have dy dx times 6xy minus 3y squared equals minus 2x minus 3y squared. And therefore, dy dx equals 2x plus 3y squared all over 3y squared minus 6xy. Now at point 2, 1, dy dx equals minus 7 over 9. We've simply plugged in the value x equals 2 and y equals 1 into the equation for dy dx. And so the equation of the tangent at point 2, 1 is y equals minus 7 over 9 times x plus a constant c. We can find the constant c by substituting the point 2, 1 into the equation for the tangent to give us 1 equals minus 7 over 9 times 2 plus c. If we rearrange this equation, we obtain c equals 23 over 9. And so the equation of the tangent is y equals minus 7 over 9 x plus 23 over 9. This brings us to the end of this session. If you have understood its contents, you should be able to differentiate functions which are defined implicitly. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.